In this first part of the activity, we needed to locate different things in the Cartesian plane. The x-axis, which is this one, the y-axis, which is this one, the four quadrants, the first quadrant, the second quadrant, the third one, and finally the fourth one. In the first quadrant, the x is positive, so as y. In the second one, x is negative and y is positive. In the third one, both are negative, and in the fourth one, x is positive and y is negative. So here are the points we needed to locate. We have a minus 3, 0, 0,5, 6,2, minus 4,7, 6, 0, 5, minus 2, 0, minus 4, and minus 1, minus 5. First of all, we located our point that was minus 3, 4. Here it is. Then for calculating the distance, which we put the letter C, we are going to use the Pythagorean theorem, and our equation is C equals square root of 3 squared plus 4 squared. C equals square root of 9 plus 16. C equals the square root of 25. And finally, our result is C equals 5. In this exercise, we need to do the same thing as we did in the previous one. We located our R point, which is this, 1, minus 1. And we needed to get the diagonal, which again we put the letter C. And we use the Pythagorean theory again, having that C equals the square root of 1 squared plus 1 squared. C equals the square root of 1 plus 1, and C equals the square root of 2. For this exercise, we just made a subtraction. In the first case, for getting a 180 degrees angle, we had 180 minus 135 equals 45. So A equals 45. For getting A in the second case, we had 360 minus 300, and this equals 60, so A equals 60. From getting A in the third case, we had 260 minus 210, which equals 150, so A equals 150. For getting the area of a triangle, we need to multiply the base times the height and divide it by 2. Since we don't have the height, we need to get it using the Pythagorean theorem. And we got an equation of A equals the square root of 2 squared minus 1 squared. A equals the square root of 4 minus 1. And finally, A equals the square root of 3. Now that we know the measure of the height, we can get our area, and we get it by multiplying the base, that equals 2. 2 by the square root of 3, and this we got to divide it by 2. These 2 and these 2, since they are opposite operations, they eliminate each other, and our area equals the square root of 3. That we have our new triangle, we got 3 new angles. First we have a right angle of 90 degrees and 2 acute angles, one of 30 degrees and another one of 60 degrees. Since we use this line for getting the height of the triangle, we already have these values. So this side is equal to 2, this one measures 1, and this one measures the square root of 3. This new triangle's relationship with the previous one, talking about angles and the measure of its sides. First of all, we have that this angle equals to the half of the original angle that we got here, which was a 60 degrees angle, and now we have a 30-degree one. The height of the original triangle became one of the sides of the triangle. Since it is a straight line and this one is 2, is perpendicular, and we have a 90-degree angle. And this measure is the half of the original side. The original side was 2 units long, and this one is 1 unit long. And this angle stayed equal as a 60-degree angle, and this side stayed equal as a 2 units long side. There is a formula that says that for getting the area of a square by only knowing its diagonal, you can do it. You can divide d squared by 2, and in our case will be 15 squared divided by 2, which is equal to 225 divided by 2, and our area is equal to 112.5. Now that we got the area, we know that for getting one side, which we need for the perimeter, we got that a side is the square root of the area. S equals the square root of 112.5, and our side equals to 10.6. For getting the perimeter of this squared, we need to multiply 4 times the measure of the side. So perimeter equals 4 times 10.6, and our perimeter is of 42.42 units. For this exercise, we use the Pythagorean theorem again. We are missing this measure, which we are going to call A. And using the Pythagorean theorem, we can say that A equals the square root of 16 squared minus 5 squared. So A equals 256 minus the square root of 256 minus 35. A equals the square root of 231, and the measure of this is 15.19. We got these values with our calculator, and the sine of 30 degrees equals 0.5, the cosine of 45 degrees equals 0.7071, the tangent of 60 equals to 1.73, the sine of 150 equals to 0.5, the cosine of 225 equals minus 0.7071, the tangent of 120 equals minus 1.73. The sine of 210 equals to minus 0.5. The cosine of 135 equals to minus 0.71. The tangent of 240 equals to 1.73. The sine of 330 equals to minus 0.5. The cosine of 315 equals to 0.7071, and the tangent of 300 equals to minus 1.73. We can see that the values for the sine are almost equal. The only difference is that we got some signs that are negative and ones that are positive. And the same thing happens with the cosine and the tangent. We got almost the same value excepting the signs. We got that the signs for sine, cosine, and tangent depended on the quadrant in which the angles were located. For example, in quadrant 1, in which angles 1 to 90 are located, the sine, the cosine, and the tangent are going to be positive. In the second one, from 91 to 180, the sine and the tangent are going to be negative, and the cosine is going to be positive. In the third quadrant, which is 181 to 270, the sine, the cosine are going to be negative, and the tangent is going to be positive. And in the fourth one, which goes to 371 to 259, we got that the sine is going to be positive, the cosine is going to be negative, and the tangent negative. Why is this? Because the values of the sines of x correspond to the values of the sine, the ones of y correspond to the cosine, and when you multiply these ones, you get the sign of the tangent, positive, 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 negative times positive, negative, negative times negative, positive, and positive times negative equals negative.